And I am now going to hand it over to CPWR's Director of Research to Practice, Eileen Beatty, to introduce today's presenters.
Thanks, Jessica. And I just want to give a little background before we get started. This webinar is part of CPWR's ongoing work with NIOSH, and we've been working with the NIOSH Mining Division to identify construction research findings that can be applied to mining, and in turn mining research that has applications for the construction industry. NIOSH and its mining division, their work on enclosed cabs is one really promising area, and it's particularly timely given the new Silica standard. So today's webinar is focusing on the requirements for enclosed cabs under Table 1 of the standard and how related research from NIOSH's mining division can be applied in construction. Our speakers are Andy Cecala, a Principal Supervisory Mining Engineer with NIOSH's mining division, Joe Coble, the Director of the Office of Technological Feasibility in OSHA's Directorate of Standards and Guidance, and Patty Downs, an industrial hygienist on Joe's staff. As Jessica mentioned, following the presentations, there'll be time for Q&A. So with that, I'll turn this over to Joe.
Yes, good afternoon, everybody, and welcome to the webinar on use of cabs for controlling silica exposure. I think this is a timely topic in that OSHA has recently published a respirable crystalline silica standard that I want to briefly summarize since it's relevant to the use of cabs, and I would give everybody a little background. It was published in March of 2016 and became effective last month, September 23rd, 2017 for construction. General industry, the effective date is next June of 2018. This standard was a long time in development. There were over 2,000 comments received from stakeholders representing over 70 organizations, including trade associations and labor unions, and 20 days of public testimony. And OSHA listened to those comments and came up with a slightly different approach to the construction standard that I'd like to talk about. If we could look at the next slide. These are the provisions of the respirable crystalline silica standard for the construction industry, and I want to focus on something that's a little bit unique and different from other health standards that OSHA has published. Because of concerns from the construction industry about difficulties in assessing exposure at construction sites, there's a lot of variability day to day, changing of the location, the type of work, the environment. They were concerned about the challenges associated with assessing exposure and in order to comply with the Pell. So in response to these concerns from the construction industry, OSHA developed a new approach where employers have flexibility of either implementing specified exposure control methods that are listed in Table 1, or the alternative exposure control methods is essentially to conduct exposure assessments and comply with the Pell. So for companies that implement the specified exposure control methods, they're not required to conduct exposure assessments, and the Pell does not apply to that operation because they've gone ahead and implemented the controls necessary to that OSHA found to be effective in achieving exposures below the Pell. So if we could go to the next slide. Paragraph C in the construction standard has specified exposure controls where if an employee is engaged in the task and fully and properly implemented the engineering controls, work practices, and respiratory protection, the employer is not required to conduct exposure assessments, and the Pell would not be enforced for that operation. Really what we heard is employers have difficulty determining when and where respiratory protection is required and where we suspect that they might exceed the PAL. So this table really lays it out, kind of a simplified compliance approach by specifying what controls are required and where those controls have found to be effective. They're not required to use respirators, and where the evidence in the record indicated that even with the controls, when conducting tasks either indoors for extended periods, then respiratory protection would be required. So the next slide, please. So the table in the construction standard lists 18 tasks, which based on the review of the published literature and comments submitted, identified as being the primary dust-producing tasks associated with construction activities. And so for each of these tasks, the table lists specified control measures, and including for some of them the use of enclosed cabs. Next slide, please. So this is the list of Table 1 entries. There's 18. It's typically tasks associated with use of power tools or equipment that has been found to generate high levels of silica and for which controls are feasible and effective, and if employers implement the controls, they'll be considered to be in compliance. Now, for 4 of these entries, one of the specified control options is use of an enclosed cab. These are for vehicle-mounted drilling rigs, for operation of crushing machines, for operating heavy equipment, to abrade or fracture silica materials, essentially for conducting demolition type activities, and operating heavy equipment for grading and excavating and earth moving activities. Now, the original proposal only had 1 entry for heavy equipment, but we had a lot of input from the operating engineers, the IOUE, who urged us to really break it out into 2 entries. Heavy equipment used for demolition can generate very high levels of silica when used to demolish concrete and brick and silica-containing materials. So there's a little bit more stringent requirements for demolition, whereas heavy equipment used for earth-moving activities, excavations, does not typically generate high levels of silica. And so one of the rationales for including this as a separate entry is it relieves the burden of employers of having to monitor heavy equipment operators when the evidence in the record suggests they are typically not exposed to high levels of silica during routine earth-moving operations. The concern is focused more on demolition activities. So what I'll do at this point is turn it over to Patty, and Patty Downs, and she's going to discuss in a little bit more detail the contents of Table 1 as well as the specifications that were developed for the enclosed cabs based on a very large part on research that had been done by NIOSH and published literature on what it takes to have an effective cab. So with this point, I'll turn it over to Patty.
Okay, great. Can I have the next slide, please? Perfect. So this slide here just shows a piece of heavy equipment being used for demolition. And you can also see that they have some wetting of materials going on down in the lower left-hand corner. So the next slide, please. Okay. So this slide shows the Table 1 entry for heavy equipment used for demolition type activities. And you can see if an employer is using heavy equipment and fully and properly implements the controls specified in the second column, then no respiratory protection is required for the operator, regardless of the duration of their exposure. And 2 critical components of this approach are that the controls are fully and properly implemented and that the employees engaged in the task are properly identified. So in order for an employer to be in compliance, the controls, the work practices, and the respiratory protection must be fully and properly implemented. And that means essentially that the controls are in place, the controls are properly operated and maintained, and that the employees understand how to use the controls. just having the controls is not sufficient. Again, the employers must ensure that the controls are properly maintained and used. Now there's a situation when you're operating heavy equipment where you have to get out of the cab and move from location to location, like when your shift is over or for lunch or for breaks. And OSHA has determined that when an operator exits their enclosed cab, that they are no longer actively performing the task, and they're considered to have stopped the task. However, if any other abrading, fracturing, or demolition work is performed by other heavy equipment and utility vehicles in the area, then that operator would be considered to be engaged in the task, and they must be protected by the application of water or dust suppressants. Next slide, please. And this is just a slide showing a piece of heavy equipment used for earth moving type of activities. Next slide. Okay. So this slide shows the Table 1 entry for earth-moving activities and heavy equipment. And this entry has two options for compliance, depending on whether or not workers, in addition to the equipment operator, are present. So Table 1 requires the application of water and or dust suppressants as necessary to minimize dust emissions. This water must be applied at rates sufficient to minimize the release of visible dust. However, if the equipment operator is the only employee in the area, they may operate from within an enclosed cab instead of applying water. Again, no respiratory protection would be required for employees regardless of the duration of the exposure. And just like for the demolition activities, the specified controls, work practices must be fully and properly implemented. Also, when the operator exits the enclosed cab and is no longer actively performing the task, they would be considered to have stopped the task. However, similar to demolition, if other earth-moving work is performed in the area by heavy equipment or utility vehicles, they must be protected by the application of water and dust suppressants. Next slide, please. So Table 1 and the Silica rule also includes additional provisions for enclosed cabs and booths under paragraph C2. And this just simply states that employers must ensure the enclosed cab or booth is maintained as free as practicable from settled dust. It has door sills and closing mechanisms that properly work, has gaskets and seals that are in good condition and work properly, is under positive pressure maintained through the continuous delivery of filtered air, has intake air that is filtered through a pre-filter, which is rated at a MERV 16 or better, and has heating and cooling capabilities. And the MERV is the minimum efficiency reporting value, and that's a measure used to describe the efficiency with which a particulate filter removes particles of a specified size from the airstream. So OSHA determined that these specifications lower the potential for dust to be resuspended inside the cab or enter the enclosed cab or booth. They also ensure that the filtered air provided to the employee does not contain silica particles, and that the working conditions in the cab are comfortable so that the employees are less likely to open windows and become exposed. Also, the procedures for maintaining and cleaning the cab and for frequent and regular inspections of the cabs must be addressed through the employer's written exposure control plan and competent person. Next slide, please. So the written exposure control plan is intended to help employers consistently control exposures by describing the tasks that could result in an exposure and the controls used to reduce those exposures, as well as any housekeeping measures. So the plan must include a description of the engineering controls, the work practices, and the respiratory protection used to limit employee exposure to silica dust for each task. So for heavy equipment, that could simply be a statement such as to operate from within an enclosed cab in accordance with Table 1. This section could also describe the equipment used and the factors that affect exposures, such as the types of silica-containing materials that are being handled in those tasks, so concrete, masonry units, tile, that sort of thing. It can include weather conditions that could affect exposures, such as wind or humidity, and also the different soil types for earth moving, such as clay versus hard rock. In addition, the procedures for maintaining and cleaning the cab or booth and for the frequent and regular inspections of the cabs and booths must be addressed through the employer's written control plan and through the competent person. And this could include things such as the cleaning methods that are acceptable, like HEPA vacuuming, cleaning methods that aren't acceptable, such as dry sweeping or blowing with compressed air, and then any special instructions. So for example, if you must use compressed air for cleaning, use local exhaust ventilation in addition to capture any dust that's blown up. So construction employers will not need to constantly update this plan for new locations as long as the plan addresses the tasks, the control measures, and the procedures used to restrict access at the location. However, the plans need to be reviewed annually and updated as needed, and they must be made available to employees, their designated representatives, OSHA, and NIOSH. And now I'll turn it over to Andrew.
All right, thank you. For the next 20 minutes, I'm going to talk to you about, as was mentioned by Eileen, the research that we've done for mining initially on enclosed cabs, and recently we've applied it to other types of what we're considering environmental enclosures. So kind of the breakdown for the next 20 minutes is just to go over a little bit of background information, then talk about some of our field research studies that we've performed. The main emphasis of my presentation, and I'm sure what you're interested in, is what we consider are the key components for an effective filtration and pressurization system. Then talk a little bit about what Patty just talked about, MERV 16 versus HEPA, and show you the research that we've done on this. Show how we've applied what we've learned from mobile equipment in enclosed cabs to control rooms and operator booths, or what I called environmental enclosures. And then last, to talk about how a pressure monitor could be used to evaluate or optimize the performance of these systems, and how it will allow you to determine whether a filter needs to be changed or there's a maintenance needs to be performed. So again, our goal going into this was to maximize the air quality and to do this by lowering respirable silica dust concentrations and other contaminants. So over the past number of years, we've personally evaluated, you can see all types of different mobile equipment, from dozers, shovels, excavators, haul trucks, loaders, but by far the most prevalent piece of equipment that we evaluated were surface drills, because based on mining, if you looked at overexposures from the regulatory agency, which is MSHA, drill operators had the highest overexposures. And these are all pictures of drills that we have evaluated and I've been involved with in looking at. And we've also done work at underground mining, drills, scalers, and roof boulders. So we have quite a history on looking at mobile equipment. Now, as you can see in this slide here, what is the level of improvement which is achieved with the filtration system? So these are all pictures that I have personally taken out performing evaluations. On the very left is it's a red dot unit, and so my question is, if the worker inside the enclosed cab thinks that he has a filtration pressurization system, but no maintenance has been done on many, many years, is it really protecting the worker? And you can see how the filter canister on the bottom is completely dented in. You can see the silica up in the evaporator coil on that. The picture in the top center is a Donaldson intake unit, and you can see that the dribbler pan is so full with product, and the filter is right to the right of that. And you can see about an eighth of the filter has a filter cake on it that, so over time, if we want to remove this, that intake filter would have probably become completely clogged. On the center is a brand new filter which was going to be put in a system that was taken out of the box. And you can see there's already holes in the filter media, which would allow the dust-laden air to flow right through these rips or tears. And then on the right is a filter that came out of a unit, another red dot unit, and you can see that the opening in the upper right-hand corner. And our speculation is when a system looks like this, there's potentially increasing the worker's exposure, not lowering the worker's exposure. So when I talk about the research that we've done, I will use the term protection factor. And all this slide is trying to show you is that there are really three terms that could be used to talk about how well a system is working. Again, we use protection factor that most people are familiar with because for personal protective equipment, PPEs, and it's nothing more of the outside concentration divided by the inside concentration. But you can see efficiency and penetration, these are all interrelated. So if I said to you this piece of mobile equipment, the filtration pressurization system is offering a protection factor of 100, it would be the same as if I said it had an efficiency rating of 99% or a penetration rate of 1%. So just realize that these terms are all interrelated. So what we've done over the years is we weren't trying to reinvent the wheel. We knew there were OEMs and filtration, filtration manufacturers aftermarket that were building these systems, and we wanted to get the most bang for our research dollars. So we partnered with a lot of these operations and mining companies and other government agencies, OSHA and MSHA, and what we would do is we would go into a facility and we would say, you know, give us your worst piece of mobile mining equipment, and then we would try and retrofit that system. So this just shows some results of some of the field studies that we performed. On the very left is the type of equipment, you know, drills, trucks, bolters, the type of mining, whether it was surface or underground in the next column, whether it was a new piece of equipment or a retrofit system. Next is the cab pressure, and the next listed in positive pressure in inches of water gauge. Then the average inside and outside dust concentration, and this is respirable dust, the less dust that would get into the worker's lungs and be harmful. And then the equivalent protection factor. And what the red arrow is showing is that there is a positive correlation with higher pressures and greater protection factors. So again, really the main emphasis now is to talk about what we feel are the key components for an effective system. So first, obviously, you have to have effective filtration, and there's two critical components to the filtration part of this, which is a pressurized intake air system that Patty talked about, and then also a recirculation component. So there are four areas that we feel are critical for a effective intake air system, and I will go through each of these separately. So the first is that we think for a piece of mobile equipment, you should have a intake air range of between 40 and 140 cubic feet per minute. And we feel from all our testing that that would be you should be able to achieve a positive pressure in the range of 0.08 of an inch to about 1/4 of an inch of static pressure water gauge. Next is that if you have a piece of mobile equipment or an enclosure where you have multiple workers, what you would need to do is you'd have to add an additional 25 CFM for each additional worker. So say you have a piece of equipment where you could have 3 workers inside an enclosed area, then you would add an additional 50 CFM to the 40, so your minimum intake airflow then should be 90 CFM. And this standard of 25 CFM is based on the ASABE 2013 agricultural standard for enclosed cabs. And what this is accounting for is the CO2 exhaled by a worker. Next is we believe that any type of intake air system should be a powered unit. And what this means is that the intake system should have its own fan. And there's 2 different types that OEMs and aftermarket companies are using, which would be a self-cleaning technique in the very left. And in this example, you could see they have a reverse pulse type system that would blow a pulse of air and blow off the dust cake from the intake filter. And the second type that's very successful is a centrifugal design. And this uses the centrifugal force to use a Venturi effect to spin off the oversized particles. So it only allows the smaller respirable size particles to reach the intake filter, and it minimizes loading and filter changes. What we don't really recommend is a static design, because what happens with the static design is you're dependent on the fan in the rest of the system to decide how much is going to be pulled through the intake, and saying that you have to have a certain required airflow, and that the intake air is what pressurizes the cab. We think it should be its own powered unit, so you always know how much air is being delivered to the enclosed area. And the last component is the recirculation component, and this is very important because the workers are always going to have some dust on his clothing. There's going to be dust in the inside of the enclosed cabs. There's going to be product on the worker's feet, and as he's in there operating the equipment, he's grinding this up. So to minimize this dust, you need a recirculation component, and it works by multiple passes through the filter. Obviously, it reduces the cleaning time for these in-cab dust sources. For this filter, we believe the range should be between a 14 and a 16 rated MERV filter for the recirculation component, and it should be 3 to 4 times the intake airflow. So in the range of between 200 and 300 cubic feet per minute. The next component, and Patty talked about this, is how important positive pressure is. And in our retrofit studies, we would always install new door gaskets and seals, and silicone caulk and foam works great for plugging in holes and areas in the outer shell, and it works very effectively. Some secondary design considerations. You want to locate the intake air as far away from your major dust sources as possible. So I'll say on a drill, if you could locate the intake point on the off-drilling side, so it minimizes loading and maintenance and filter changes. Patty talked about this also, the importance of keeping the doors and windows closed. So this was a study that we were doing at a drill at an operation in Alabama. And for this drill, they were using 3 drill steels. And this operator had to actually open the door and manually guide the new drill steel in place. This isn't typical for most drills, but you could see on the graph on the left, when the driller was actually drilling and operating, his exposure from an instantaneous dust monitor measuring respirable dust would be the navy blue segments. And when he would open the door to guide the drill steel in place, and I have to state that this was at least a minute after he was completed drilling, and so most times, as you can see in the picture that I've taken, that you couldn't see any visual respirable dust, which you can't see, but obviously it was still in the pit or the quarry there. And so what this is showing is when he opened the door to guide the drill steel in, you can see his exposure was 0.81 milligrams per cubic meter. So his exposure, even though he wasn't drilling, was 9 times higher than when the door was closed and he was actually drilling. The other thing that we've identified is in some units we've seen these floor heaters, and again you can see all the product and material on the floor from the workers' boots. And what this did is it just stirred up all this dust as the worker would move his feet around. So we published some information that stated that we definitely don't recommend any type of heater located on the floor, and as I think Patty stated, we recommend the heating and air conditioning be delivered through the filtration and pressurization unit. The other component is, as I showed in those initial examples, if you can't change the filter over time, it's going to be completely ineffective. So when you're working or designing a system, really design in a system that you can easily change all the filters. And we recommend a MERV 16 mechanical filter. With a mechanical filter, it becomes more efficient as it loads with dust. And I'll show you some information later on in the presentation. We recommend in almost all cases MERV 16 for the intake filter because a HEPA filter is just too restrictive and it creates other problems, and we'll show you more about that. This is the, Patty talked about this, this is the actual MERV rating table, And you can see at the very bottom, Patty presented this information. A MERV 16 filter is rated at greater than 95% efficiency from really 0.3 particles all the way up to over respirable size particles. A HEPA filter is 99.97% effective at these same ranges. And the problem with this is the filter is so restrictive to begin with, and so much pressure drop across the filter that it loads up so quickly. And we believe it's more designed for control rooms or operating rooms for clean rooms, but not for, in most instances, mining or construction sites. And we'll show you some information on this also. So here's a test that we performed at an underground limestone mine in Ohio. We tested these two pieces of equipment, which was a face drill and a roof boulder machine. We tested a MERV, all the filters as MERV filters in 2013, and then repeated the test in 2014, May through November, with the HEPA quality filters. And we would perform testing using particle count instruments, one inside, one outside, to determine the protection factor. And we tried to do everything the same for exactly the same two tests. This was the filtration and pressurization design that we were testing with an intake, a recirculation, and then everything went through a final filter. So this shows you the system that was evaluated. And here you can see that when we look at the MERV 16 versus the HEPA, really there was no statistical difference in the protection factors. Now, obviously, the protection factor was higher for the face drill than the roof bolter, but there's other issues that's I don't have time to get into. But if you compare the HEPA and MERV 16, they were very, very similar in this case. The one difference here on the face drill is when the filter was brand new, the blue shows the MERV 16. So we started in May with a airflow through the MERV 16 filter of around 70 cubic feet per minute. In November, we still had over 33 cubic feet per minute of air being delivered to this face drill. In the following year, when we tested the HEPA filter, you can see we started at around 50 CFM, and as the filter was already so restrictive, it overloaded, so we had to change the HEPA filter 3 different times because the airflow dropped below 25 CFM. So you can see how much quicker the HEPA filter loaded up with dust and needed to be changed, and you really didn't increase your protection factor because of the less airflow. So we took this information, as I mentioned to you, and we applied it to other types of environmental enclosures. We did a study at a crusher operator booth in Wisconsin, a control room in New Jersey, and a crusher operator booth at an underground limestone mine in Pennsylvania. And I'll quickly go through these examples. So this was an operation, you can see outside, that on the left, the 2 photographs show the crusher operator booth before. They didn't feel that this booth, they could achieve positive pressure, so they actually bought a new booth and installed it. And this was the system that we tested. It was a polar mobility system, an HVAC, and filtration system. We looked at various parameters that you can see in the graph from 2 intake filters and 2 recirculation filters, and looked at combinations. But as you can see, for the various combinations, we averaged, or we obtained a protection factor between 35 and 127 with this system, which is great, a great improvement into the air quality. This was a control room at a silica sand operation in New Jersey. We performed baseline testing. We actually installed the new system ourselves over the weekend, where we had to bust out a few blocks and install the new unit, and then we're ready to go the start of operation on Monday, and then tested the new unit. So we tested it, and then because levels are so low to begin with in a silica sand operation, we returned almost a year later, and the same filter was still being used. And this shows you, as the filter loads up with that dust cake, how it becomes more efficient. And this was a cyclone design, and you can see it was a protection factor around 8, and then as you attain the dust cake, the protection factor went up to a protection factor of 25. Okay, and the last was at an underground limestone mine in central Pennsylvania. This was they moved the crusher, primary crusher from outside to underground, this was a Canadian-owned company, and they actually bought this crusher booth. It was a Canadian-built crusher operator booth, and we were up doing some additional work, and we were told them that we were doing studies in this area, so they asked if we would evaluate their booth. So this booth was purchased, and it didn't have any filtration system. So when the fan, which you can see in the photo on the right on the roof of the crusher booth, was used, the worker's exposure was 6,500 micrograms per cubic meter. The operators knew that it was blowing dust in, and so they normally were operating with it off. It was only 530 micrograms, but obviously you don't want to be in a situation where you're not providing any fresh air to a worker inside an enclosure. So what we did is we installed a cleaner filter unit. You can see on the top right. It was a single filter design that really filtered the intake air and the recirculation air. This shows you we looked at both a HEPA quality filter first and then a MERV 16 filter. And you can see that the MERV 16 filter was 4 times greater efficiency or more effective than the HEPA filter. And the reason being, again, because the HEPA filter was so restrictive, it decreases the amount of air that's actually able to be cleaned. And again, the filter needs to be changed so much more regularly than a MERV 16 filter. So this supports what our hypothesis was, and it proved out to be the case, is that we believe in almost all applications for mining and construction that a MERV 16 intake filter is the optimal design. And then I mentioned about the pressure monitoring system. So basically when you start with, so you can see what the pressure was on the left with the HEPA filters, and then on the right with the MERV 16 filters. And so what this shows is when you start with a new filter, you have a certain pressure, and then as the filter loads with a filter cake, it decreases. And then if you're watching your airflow, when you see what a certain pressure range is, then you can just say, okay, when we reach this pressure, this is the time to put a new filter in. And obviously, if the worker's looking at the pressure each day, he can see if there's a major failure, maybe somebody did maintenance and forgot to put the filter back in, or there's a rag or something that got sucked into the system. So the pressure monitor gives the worker a great indication on the effectiveness of the filtration system. So most people have heard the term where the rubber meets the road. Well, we've kind of phrased the term, you know, where the dust meets the lungs. And I have to be honest, when we were testing out at the underground limestone mine in Ohio, we would meet with the crew every couple months and show them the results and buy them lunch and stuff. And when we're showing them the graphs and all the information, you know, they're looking at it. But I think the thing where the light bulbs actually came on is when we actually showed them the filters that were on the outside of their mobile equipment and on in the inside. So you can see for Wednesday, July 30th, for both the roof bolter and the drill, and the workers saw that without a filtration and pressurization system, this is the type of contaminant that would have been getting into their lungs, and how much cleaner it was because of the filtration and pressurization system. It really caught their attention. We produced a video a number of years ago called The Faces of Black Lung, and it highlighted 2 underground coal miners. And the one miner, Chester Fike, that's shown in the center photo, he had a double lung transplant. And so this is his actual lung that was removed. Now, obviously, he was a coal miner, but obviously you can see the effects of respirable dust on a worker as he works in a dusty environment over his career. So happy to say that what we've, the work that we've done, we've gotten great interest from many different companies. We've worked with Caterpillar, with Fletcher. You can see the list on the right of different OEMs. So we've had a great impact, and you know, we hope that this these filtration and pressurization systems become common practice on all new mobile equipment and control rooms, operator compartments, any type of environmental enclosure. So that completes my presentation. I thank you for the opportunity to share with you what we've learned from mining, and hopefully it can be beneficial to you in construction.
Great, thanks so much, Andy, and thank you, Joe and Patty, as well. If anyone has questions, now is the time to start typing them in, and I'm going to go ahead and start with a couple that have come in already. First, we've been getting a couple questions about whether I will be sending out a copy of the presentation. So I'll go ahead and let everyone know that, yes, in addition to a recording of the event today, I will also be sending out a PDF of the slides. It should be either tomorrow or Friday that you will receive that. And then there's a question here that probably will be for Andy, but I'm not sure. Any recommendation for CO monitors in these cabs since they are now better sealed?
On that, as long as you're, we did look at those levels, but as long as you're maintaining your intake airflow, that should not be an issue. Now, if you feel comfortable with putting one in, that's fine. But as long as you have a minimal of 40 CFM, you shouldn't. That should be not. It shouldn't be an issue at all. So.
Okay. And the next question is, what are your general recommendations to the industry and to OSHA in regard? Sorry, hold on, I lost it. In regards to these findings. So sorry, the whole question is, what are your general recommendations to the industry and to OSHA in regards to these findings? That's for you, Andy.
Well, we actually did give our input to OSHA before they came out with the standard. So, I think they did a great job in incorporating these. I guess my only concern is that if you're using an effective system, but as my slide showed early in my presentation, just because you have a system in place, if it's not maintained, if the filters aren't being changed. For instance, if you have a pressurization, filtration and pressurization system and you remove the filters, so basically what will happen is you'll be blowing the air from outside into the enclosure, and because there's no restriction from the filter, you'll see an increased pressure because you're just blowing the air right into the enclosed cab. So you could assume, well, we're really getting a great reduction in dust, but in reality, you're not filtering the air. All you're doing is blowing air from outside to inside and pressurizing your area. So I think that, you have to ensure that if you're using these systems that they are maintained and that they're working properly. And that's why we feel that the use of some type of monitor, a pressure monitor or something like that to indicate the effectiveness is definitely critical.
Okay. This is a question for OSHA. Now that this is in the Silica standard, are all manufacturers modifying their designs? Are most of the changes from original equipment or retrofits?
Well, this is Joe, and I know that based on what Andy showed on his slide, manufacturers are adopting this technology, and so pressurized booths are now, in many cases, standard equipment. We did have a lot of concern about older equipment that does not have a booth, that cannot be retrofit, and that type of equipment would not be suitable for demolition work unless you're prepared to do the exposure monitoring and demonstrate that you are effectively controlling the dust through the application of water or work practices. So it's not like you can't use older equipment that doesn't have a booth. You just have to take the extra steps of doing the exposure assessment and assuring compliance with the Pell. Whereas if you do opt to buy equipment or retrofit a booth, then that eliminates the need to do exposure monitoring and it makes your life simpler. It's just a matter of properly maintaining the booth and making sure that, for example, you don't have accumulation of dust all over the inside of the booth. If an OSHA inspector took a look in there, then they would question whether or not you truly have fully and properly implemented that control. So I know that there's a lot of interest in buying equipment that complies with Table 1 to make life simpler for the construction industry, and to a certain extent, this is a technology forcing standard.
Okay, thanks. And in follow-up to that, regarding cab cleanliness, the question is, dry sweeping and use of compressed air is not acceptable, if I heard correctly. Could a damp cloth be an alternative mechanism to maintain cab cleanliness? And do contractors need to do anything to prove that this is acceptable?
Patty, you want to address that one?
Sure. Yeah, so using a damp cloth would be fine. I mean, you could also use a vacuum to vacuum out dust. No, I don't think, Billy and Joe, correct me if I'm wrong, there's no requirement to prove that using a wet cloth is acceptable. Really, the intent of not allowing dry sweeping or the use of compressed air is to prevent that air from becoming resuspended and then having the employee breathe it in while they're cleaning out the cab.
And this is Andy. I'd like to add to that. We did a study where we put some sweep compounds down on the floor in enclosed cabs, and they are effective until you're able to clean it out to absorb the dust and not allow the dust to be liberated. The only thing that you have to look at is if there's chemicals on the sweep compound. That's something that you have to look at the MSDS to make sure that there's not an effect from any chemicals on the sweep compounds.
Okay. The next question is, I'm not sure if anyone has numbers on this, but what percentage of earth-moving equipment currently in use provides the required enclosed cab protection, i.e. backhoes, scrapers, etc.?
This is Andy. I'll go first on this. I know we don't have any of that information for the mining industry. One thing that I think would be very beneficial is that really what it's going to take to change this, talking with some of the OEMs, you know, they will offer filtration pressurization systems, but it's not a standard feature because, I mean, it's kind of crazy, but, you know, these systems probably would increase the cost to a piece of equipment in the range of probably $5,000 to $10,000, and an OEM is not willing to lose, even though a lot of these pieces of equipment could be hundreds of $1,000s and much higher, they're not willing to lose the sale of a piece of product by adding something on that the customer really isn't interested in. And I think a key, especially with the new OSHA standard, is that you know, the industry should not be willing to accept any piece of equipment that doesn't have a filtration and pressurization system to protect the operator. These OEMs, they always filter the air that goes into their engine because, you know, they don't want to lose an engine, but you know, in the past, they really weren't concerned about filtering the air going into the enclosed cab because, you know, that wasn't a requirement. So I would hope that you know, the mining and construction industry really can pressure the OEMs and really not consider this unless they have effective systems to clean the air going into the operators.
Okay. There are a couple similar and related questions about, what equipment today sort of meets these requirements, what percentage of new equipment meets these requirements. And so I guess I'm just going to try to summarize them. Do you have any, based on the tests that you have done, do you have information or those test results that would provide a good picture of what heavy equipment being used today does sort of meet these standards as far as the cabs go? If somebody, I guess, were to purchase new equipment, do you have something based on your test results that lays out recommendations for how they should go?
This is Andy. I mean, we have publications on all the work that we've done, and we've also have a publication basically on what I just presented, what are the key components. But again, we don't have any information on, what systems by what manufacturers meet the recommendation, or what equipment even from each manufacturer. Joe or Patty, do you have any information on that from OSHA standpoint?
Well, as part of our feasibility assessment, we determined that these systems are commercially available and can be purchased. We didn't necessarily do a market survey to see how many people are buying the enclosed cabs versus equipment without cabs. Our suspicion would be that that will be changing over time once people understand that compliance with the Silica rule is greatly facilitated by simply buying a piece with a cab. Although, as I mentioned, for a lot of earth moving activities, excavating, the Table 1 does not necessarily require an enclosed cab, provided you're taking some dust suppression methods using water, which many, what we heard from the operating engineers is that a lot of construction sites where heavy equipment is moving around are already required by environmental regulations to do simple dust suppression using water, gravel, limiting speed. They have to have a dust control plan in place, just even for visibility and worker safety. So if you take those precautions, you wouldn't necessarily have to have a cab on your heavy equipment unless you are demolishing, fracturing, doing a job that's known to be generating silica dust or abrading fracturing materials known to contain silica. So for that subset of operations, it makes a lot of sense to buy equipment that has the enclosed cabs that meet these specifications. For the vast majority of construction work using excavators, as long as you're implementing dust controls, you don't necessarily have to have the enclosed cab. However, if you do have the enclosed cab, then you don't have to take the extra measures of dust suppression unless there's other workers in the area that are potentially affected. So I don't see that this is going to say all equipment must have an enclosed cab. It's only equipment that's going to be used for fracturing or demolishing materials known to contain silica. And maybe an employer with a little more foresight might want to get the enclosed cab just to control the dust in the first place, regardless of the silica content.
Okay. And is there an easy way to determine the effectiveness of a cab in keeping levels below the PL, below 25, or in order to meet these recommended features?
Joe or Patty, do you want to answer that?
Well, I think Andy sort of alluded to the fact that if you have a pressure indicator and you do a regular inspection and you are maintaining the positive pressure and the filters are clean, that's probably the easiest way of ensuring you're not going to be exceeding the PEL. I mean, there are direct reading monitors. You can do inside-outside sampling, but that tends to be more done in a research setting. The periodic monitoring of heavy equipment operators at construction sites can be a little bit burdensome. So our thinking was just use the controls, use the cabs, properly maintain them, and that's your best way to ensure that people aren't going to be overexposed.
Okay. This question is for Andy. In your presentation on crusher booth, the slide lists a huge range of protection factors following install of filter. Do you have a recommendation for a protection factor you need to design for?
Well, we've actually designed a mathematical model. So really, if you look at what your levels are, and the system really can, you could design a system to meet, if you can look at like a range of what type of outside exposures, you know, we could work with companies using this mathematical model, and it could tell you what you would need to reach the standard in your application. You know, and that's why, you know, with the HEPA, you know, most people today, as soon as they, you know, think about we have to filter, we need to use a HEPA filter. Well, you know, what we showed is that the HEPA filter is really so restrictive and loads up so quickly that it's not the best application when you're dealing with, you know, dusty environments. And so it's hard to say. It's really, if you can look at ideally on a case-by-case basis if you're designing a system. But if you're getting a system from a manufacturer, an OEM, a piece of mobile equipment, their engineers will design a system that will work for you. It's just, you know, on a crusher operator booth, if you have a booth, say, and it doesn't have a system, you know, we could work with you, or I'm sure OSHA could work with you to help you design a system that would meet your needs.
Okay. This next one is for OSHA. Would these recommendations apply to general industry, specifically foundry, where employees use enclosed cabs where there's a silica exposure not related to construction, even though it isn't in the general industry silica standard? Even though this isn't, sorry.
Yeah, no, Table 1 only applies to construction activities with a small exemption if, say, utilities or people who technically are general industry but are doing tasks indistinguishable from construction activities, they can also follow Table 1. But a foundry that's a fixed establishment where you might be operating heavy equipment to move sand or something like that, they would have to conduct exposure assessments and comply with the Pell. Table 1 does not apply to foundries or general industry.
Another question for you is for item, I believe that's 17, sorry, I don't know my Roman numerals, on Table 1, why isn't there an or option, an and or option? If the dust is controlled for workers on the ground by a wet spray, why isn't that enough control for the equipment operator as well?
For the demolition activities, we require a booth. You don't necessarily have to use water unless there's other workers in the area. So it is something of an or option triggered by the presence of other workers. So if you're doing demolition in an enclosed cab, water is only required if other workers are assisting with or engaged in that task. So the primary control for demolition is use of a cab, supplemented with water where other workers are present. For non-demolition activities, you have the option of using water or a cab, and water is only required, again, when other workers are present, but you don't have to have a cab for, and you can still comply with Table 1 for earth moving. You do have to have the cab for demolition, and you have to have water also when other workers are present.
And just to piggyback on what Josh said, I mean, mostly OSHA came to that determination because the data just didn't support using water alone would be enough to control exposures for equipment operators.
We have another Table 1 question regarding use of milling machines. Table 1 says to use a surfactant when using a milling machine. What chemical should be used?
I think there's a variety of products out there intentionally made as surfactants. There's typically a detergent type of soap surfactant that can be added. I don't have the exact chemical formulations, but they are commercially available and intended for that use.
And NIOSH has a bunch of information about road milling and using drivable milling machines on their website and the different types of surfactants that they've studied.
Yeah, I'd like to say, this is Andy. We worked with our coworkers from Cincinnati, DART, and we had a cooperative effort with the National Asphalt Pavement Association. And we did an in-depth study, and even OSHA was involved in the evaluation at the end. So there's a number of reports that have been published, and so you could go to that information. But we showed that, what suppression and also an LEV, local exhaust ventilation system, on road milling machines are very effective. So Dwayne Hammond is the lead author, so if you even looked under his name, Hammond, he would be the lead author on the NIOSH publications that describe this work.
And if anyone has trouble finding that, if you're looking for it, you can follow up with me via email, and I can help track that information down. Okay. We are hitting our time limit, so I have just a couple more questions here about back to the filtration. The first is, my understanding was a HEPA filter was required at 99%. What is the requirement for the standard? 95%?
Go ahead, Patty.
You there, Patty?
Yeah. So I think you're just asking essentially what the required filtration rate is, and the standard just specified that it has to be 95% efficient in that 0.3 to 10 micrometer range. So it's essentially the equivalent of a MERV 16 or better.
Okay.
Does that answer the question? So
I think so, yeah. And then the next question is, what is the average expense to outfit an excavator cab with a Table 1 compliant filtration system?
I'll say there's a lot of different, if you needed to do a retrofit system, there's a lot of different aftermarket manufacturers from, some that I mentioned, I'm not trying to endorse, is Cyclone, Polar, Red Dot, Clean Air Filter, Sigma, Bergstrom. We've worked with all these manufacturers, so, I'm sure if you would, I hate to say it, like Google filtration pressurization systems, contact all these companies, and if you want, I mean, you could give me a call. I'd give you the list, and see what they could do for you. But we've tried to spread it around and work with as many of these as we could over the past number of years. So we've been working in this area for over a decade, and they're all building systems that will meet the requirements.
Great. Okay. All right. One final question. Have you developed any guidelines on how often the MERV 16 filters need to be changed based on outside dust concentrations, similar to what filter manufacturers do for home HVAC filters?
Well, again, from our testing, because every application is different, you could have a piece of equipment that's operating in an outside concentration of 10 milligrams and one at the same location operating in an outside concentration of 15 milligrams, five times higher. So we feel the key is and as I showed in the presentation, when we recommend the use of mechanical filters, so as the filter develops that dust cake, it's more effective. You know, for instance, at the silica sand operation, a year later, the protection factor went from 8 up to 25. So that's where we recommend, if you look at the pressure and the airflow, that will provide the best indication on when the filter needs changed. Again, you don't want to change the filter until your airflow drops down to a level that it's not sufficient for pressurization or for the CO2 issue.
Okay.
Yeah,
and there's one more question. Oh, sorry, go ahead.
Oh, no, I was just going to say, as far as the standard is concerned, OSHA didn't specify a specific timeline. Instead, we just stated that you need to include that information in your exposure control plan, just because, as Andy said, there are so many variables, and what may be a great maintenance and filter changing schedule for somebody in one part of the country who works with a specific type of soil may not be anywhere near what's right or what's best for, you know, a similar piece of equipment working in a different region.
Sure.
So really the only requirement is that employers write down what their plan is to monitor, you know, the filter efficiency and to inspect the cabs to make sure everything's working properly in their written exposure control plan.
Okay. All right, one more last question. Demolition often occurs during the winter months. Water generates a freezing ice hazard, an immediate risk. Any suggestions to approaching that?
Sure. So
well,
we found.
Oh, go ahead, Ben. Okay.
So we found in the comment period that some people have, you know, commented some of the effects of freezing temperatures by using environmentally safe antifreezes mixed in with their water to prevent it from forming ice and sleet.
And there may be enough moisture during the winter if there's traces of snow around that just you don't need to add extra water. And again, for demolition, you only need water if you are exposing employees outside the cab. So you could conceivably conduct a demolition project inside a heated, air-filtered cab, and as long as you don't have people out there exposed to the dust, that would be acceptable under Table 1 without the use of water.
All right. There may have been a couple questions that I skipped over, in which case I apologize. Again, I was just trying to keep it to our timeline. So if you do have questions that did not get answered during the event, feel free to email me. I will follow up with our speakers and get you the answers that you are looking for. And again, I just want to thank everyone. Andy, Joe, and Patty, thank you so much for doing this presentation. And I will be, again, sending out the recording and the slides by the end of the week. Thanks again.
Okay. Thanks, everybody.
Bye, everyone.